My name is Kevin Silbert from Maritime Applied Physics Corporation, and I'm joined with Kevin McKee and Kyle Mosenson to present our idea for a deployable bow bumper. Our deployable bow bumper system consists of an inflatable bumper that's held in place by a structural system around it. The structural system consists of a metallic top plate and a structural stiffener lower plate. The top plate has a non-skid upper surface and a hypalon-lined lower surface to allow some compliance on the deck and reduce wear on the carbon fiber. And the lower plate is more of a stiffener to prevent it from opening up with axial loads. It's held in place by a bridle and some ratchet straps that attach to the lifting points on the front of the vessel. The inflatable bumper consists of several drop stitch inflatable bladders. Drop stitch is a manufacturing technique for inflatables that has an upper and a lower skin separated by high modulus tensile fibers that allow increased structural strength and higher pressures. These are arranged in a fashion and then covered up with an outer cover that's bonded in place and sealed over the top. There are also attachment points that are bonded into the bladders themselves and cutaways over the outer cover. We use these to attach these upper and lower plates. There's also a fill port and a pressure relief valve to allow filling and release any overpressure. The top plate is treated with a molten aluminum deposition process, a non-skid surface that is known as slip knot. The inflatable structure, the inflatable bladders and plates themselves add up to 68 pounds of weight to carry the 5,000 pound load capacity plus 1,000 pounds of dynamic load. These can be inflated to 21 psi by either an air pump or a tank. And from the previous slide, you'll note these inflatable structures, multiple structures, they're all bonded to each other, and the outer skin is bonded to the entire system. There's an image in the bottom right of a sponson that we have for a different project here, where you can see how some attachment points are bonded into the top surface. There's an aluminum bar, and there's also a stainless steel D-ring, and you'll also see the inflation and fill and relief ports. At 21 psi relief pressure, with 312 square inches that the design currently has for the bow plane, we can withstand 6,552 pounds of capacity before the relief valve would open up. The relief valve does reset, so if there's a momentary surge, it will burp out some air and relieve pressure, but it will not dump all of the pressure out of the tube. To stow the system, it can be stored either fully inflated or deflated if storage space is at a premium. In the bottom left, you'll see an 18-foot beam that we have in the shop that was deflated for stowage and takes up less than 9 vertical inches of room. In the upper right corner, we have a concept for rigging for fully inflated stowage with the ratchet straps up on the top. The picture below that on the left is showing that you can actually fit 2 of these in this condition into a 4x4 by 2 foot stowage locker. Or if you deflate it, the picture on the right shows that you can get it up to 6 in that same volume. To point out the features of this design, we'll start with the inflatable cushioning structure. This allows compact stowage, but a large volume fill for lower pressures on the vessels. There's compliance in these inflatable systems that allow for imperfect and varying contact conditions while these vessels are at sea. And there's cushioning inherent in the inflatable structures that will protect both hulls. We use a drop stitch inflatable to allow an increased pressure limit so that we have reasonable contact areas for these bumpers, smaller than a conventional fender, if you will, boat fender, and also increased stiffness from the higher pressure. There's an aluminum framework to allow a repeatable interface location on the bow of the vessel, and on the lower surface, it provides stiffness that prevents the bumper from just bending open and not providing any impact protection. But these plates, as noted, collapse when you air down and release the pressure, allowing for compact stowage. There's a pressure relief valve to prevent any sort of overload or catastrophic failure situations. There are ratchet strap attachments that we chose because they're low profile, minimizing the trip hazard for people walking nearby, but they stow in a compact fashion. They're adjustable straps, so they can handle ship variances. manufacturing tolerances and that sort of thing. And they can be cut away in any sort of emergency where this thing might need to be removed even quicker than the conventional means. And actually the side bridles can also be used as carrying handles. We do not interface with the tow bar, the stem tow bar on the vessel. And the benefit of that is we can easily inspect all of our connections while operating at any time. And there's no chance of having a fouled connection or a fouled release in an area that's hard to get to or inaccessible during operations. We have surface treatments on the top plate, including that slip knot, trademark non-skid fused aluminum deposition, if you will. Very, very aggressive surface treatment for non-skid for safety, and a Hypalon coated lower surface to balance against hull imperfections and reduce point loads and hull damage. It's also an expandable design concept. It can easily be seen that this different bladders of different shapes could allow more side variants, sideboarding and that sort of thing for underway vessels using alternate conops. We've developed a notional installation procedure that starts with opening the locker and topping off the pressure in the air bladders if needed. We note that temperature changes and storage time will affect the pressure. And if the deployment time is critical, we definitely recommend topping off that pressure earlier, but this step can be performed at any time. Step 3 is remove the ratchet strap ends and attach them to the bow lift fittings while the system is still in the locker, and loosen up the captive straps. This will allow a sort of captive deployment where we can remove the bumper from the locker and carry it forward while those straps are attached and preventing accidental loss overboard in the event of an emergency or an accident. Side bridles can also be used as handles on the bumper itself. Lower the system over the bow and tighten up the ratchet straps and you're ready to go. We believe a single installer can easily do this in less than 5 minutes. The slide shows a list of components and their weights, certainly for the critical hand-carried components. We've tracked their weight closely. There's an Excel file on the deliverable file list that has this information also. As a demonstration of the capabilities of a drop stitch inflatable, we dropped a rough concrete block onto an inflated drop stitch sponson that was inflated to 21 psi. As you can see, the sponson held up to this abuse quite well. It is proven quite strong and durable. We believe this concept holds great potential for an affordable and simple bow bumper that can be used for this application. We think the next steps involve some prototyping and testing, and those are steps that Maritime Applied Physics Corporation is very comfortable performing. We've done this on several other related projects. You can see in the upper right corner we've built the entire 40-foot set of inflatable sponsons that actually is used to recover ribs onto the LCS craft. It has very similar properties and has recently switched to a drop stitch inflatable. And we've also done several other sort of launch recovery and deployment projects, as well as complete vessels, autonomous and manned. So we look forward to your response about this project and are eager to help where we can. Thank you for your time.